myself Ketan Bhavsar, Assistant Professor in LJ Engineering College, Ahmedabad. In this session, we discuss about embedded system, and in particular topic we are considering this section. It is a classification of processor interrupt service mechanism for context switching angle. From chapter number 3 about device driver and interrupt service mechanism. So now we go ahead and we discuss in depth. So first of all, we are very familiar with the word 8051, right? Because in previous or we can say that before few years we already heard this name 8051. 8051 is the first microcontroller which is very popular in that days. So 8051 interrupt service mechanism is such that on occurrence of an interrupt services, the processor puts the processor register PCH, means program counter higher byte, and PCL program counter higher byte in terms of the lower relations onto the memory stack. The 8051 family processor do not save the context of the program other than the absolutely essential program counter, and a context can save only by using a specific set of instruction for that. For example, using the push instruction in ISR. So basically, if you're talking about the interrupt service routing mechanism, then we have to focus on these two parts, PCH and PCL, in terms of the higher byte and the lower byte variations, right? And for that, we have to considering specifically a program counter. Means based on the program counter, it will vary the instruction set. Now, advantage of saving the program counter only in 8051. It spend of the start of ISR return from the ISR, but at a cost. Definitely, it takes a cost in terms of the processing speed as well as for processing clock. So the ones of context saving is on the program in case of context, means SP and CPU register other than the PCL and PCH to be modified on the service of one function call during the execution of the remaining ISR instruction. Now 68HC11 interrupt service mechanism. This one is a very popular microcontroller on those days. Basically, we are focusing about the Motorola. Right? So processor register saves on the stack whenever an interrupt service occurs. So these are in the order of PCI, PCH, IYL, IYH, IXL, IXH, ACCA, or and CCR. So basically, in that case, we are to focus about the higher and lower byte of the registers, and in that case, we are considering of the processor instruction set. Means we are talking about specifically the processor instruction at that time. So 68HC11 thus automatically saves the processor context, of the program without being show any instructions in the user program. So 68HC11 interrupt mechanism as a context switching, it takes the processor time. It slows a little at the start of the ISR and return from the ISR, but at that the great advantage that the ones of context switching is not there on the programmer, and there is no risk in case the context modification of the service or function cell. So basically, in that mechanism, we have to focus on 68HC11 interrupt mechanism, and for that we have to save each and every instruction set for time. Now the very popular microcontroller that we already heard about is ARM7 interrupt mechanism. So ARM7 is provide a mechanism for fast context switching between the two tasks, one current and one at the stack. So basically, one means the current execution going on, and second one is it is available in the stack. Multi-byte data set or burst of data or block of data. So basically, if you're talking about the multiple bytes instruction set at a time, multiple data is transmitted at a time. So a DMA requires when the multiple byte data set or a burst of the data or a block of data is to be transferred between the external devices and the system or two systems. So basically, we are talking about the DMAC, means DMA controller. So DMA controllers play a main role when you have to transmit the data from one side to the another side. For single purpose processor unit that facilitate the DMA transfer. So basically, in that case, we have to focus on a DMA instruction set. Means we have to transmit the data from one side to the another side only. Using a DMA microcontroller. So DMA based method is useful when the block of byte are transferred. For example, from disk to a RAM or RAM to the disk. So basically, it play a main role when we have to perform some specific task. Repeatedly interrupting the processor for transfer of every byte during the bulk transfer of the data will waste too much of the processor time in context switching. So basically, in that case, we are wasting so much amount of time for the data transmission unit, right? It's a DMAC, means a direct memory access control. So system performs improving by separate processing of a transfer from and to peripherals. For example, between camera memory and the USB port. So it can be easily transfer the data from one side to the another side. So we can directly communicate with the multiple data user at a time. So as you can see in this particular example, you can see the RAM is over here, processor is over here, DMA, and the port it want to communicate, and here is a device to send or receive from the RAM. So basically you can see the processor is over here and the memory is also connected over here. So basically what direct memory controller what exactly did, the main work of direct memory access means what it directly communicate with the RAM to the port. So if the processor is busy for executing the some specific task, so at that time your task will be carry forwarded or it will not wasted by the DMA control. It will directly send to the DMA, and DMA is according to that it will send a data to the RAM, or it can be start the handshaking between RAM and address of the port. So it can be directly communicate or handshake with a process control block if a processor is busy for executing some specific task. So basically DMAs play a main role when you have to communicate with any other type of devices. Direct memory access is play a main role whenever you want to communicate the data from source to destination or destination to source. It plays a main role when you want to communicate with the processor. So processor is in center part, RAM, and basically DMA it is another part. So basically you can see the processor it is in center position, and the RAM and DMA controller it is in one, or we can say that one or second position. So it can be directly communicated as you can see. So there is no need to use additional memory concept or additional data acquisition system. DMA hold request. After the ISR initiated and programmed the DMA send the hold request to the CPU. CPU acknowledge that if the system memory buses are free to use, first of all it have to check single transfer at a time and then release of the hold on the system bus. So basically it's a three mode: single transfer at a time and then release of the hold of the system bus, burst transfer at a time and then release of the hold of the system. So burst may be in terms of kilobyte, and the bulk transfer and then release to the hold of the system bus after the transformation is completed. So basically DMA controller is generally working in three different types of modes, and these three different types of mode is generally communicate in terms of the single byte, or we can say that the bulk transfer, or in terms of the byte informations. Now DMA processor without the CPU interfacing. If we are talking about the DMA without CPU interfacing, then how it is possible? Expect one at the start of DMA program and initiating, and second at the end. So basically we have to initiate the program and then we have to end the program. So whenever the DMA request by the external devices is made to the DMAC, means direct memory access control, the CPU is requested by using the interrupt signal. The DMA transfer by the DMAC at the start to initiate the DMAC, at the end to notify the end of the DMA by DMAC, means in terms of the direct memory access control. Now, if talking about the DMA controller, then we have to follow some few steps. When the DMA controller is used to transfer the bulk of byte, means ISR is not called during the transfer of the bit, and ISR is called only the beginning at the transfer of the program to the controller, and another ISR is called only at the end of the transfer. So basically we have to call the ISR, but in terms of the two situation only. First of all, when we have to initiate the program in terms of the beginning of the transfer, or after that we have to end of the transfer. Now programming the DMAC register, then how you can program the direct memory access controller. So the ISR that initiate the DMAC, means direct memory access to the interrupt source, simply program the DMA register for that. Command mode of transfer the bulk or burst of the byte. Data count means number of bytes to be transferred. Memory block address, where the address to data is made, and IO bus for the start addressing of external devices. So basically we have to program the direct memory access controller is like this. Now use of direct memory access channel for facilitating the small interrupt latency period sources. The small latency period can be set when using the DMA channel when the multiple interrupt for the IO source exists. The ISR run period from start to end can now be very small, only in terms of the short code for programming DMAC. Fine. So we have a very small amount of codes, and in terms of the code byte only, so we have to communicate from source to destination at a time. Multiple channel DMAC means provide the DMA actions from a system memory and the two IO devices. Separate set of the register for programming each channel and separate the interrupt signals in case of the multi-channel DMAC. So we have to separate the address in terms of the communication point of view, right? Because without the address we cannot start communicating. So if we have a multiple number of channels, then we have to separate in terms of the multiple channel DMAC, and rather than we have to directly facilitate it, or we can say directly we can communicate with a single channel. So basically here we are talking about a DMAC programming of the specific registers, means how you can start communicating, right? So 8051 family members means 83C15 to JA and its sister JB, JC and GD microcontroller to DMA channels on chip. 80196KC has the PTs with peripheral transaction servers and the support DMA functions. So basically here we can consider the two different types of channels, and each and every time we have to start the communication on the two DMAC at a time. So I hope that you are getting the idea of what exactly DMA is, how actually DMA controller work, how we can communicate and program with DMA registers, and how we can start communicating with the registers with the other microcontroller. Also, we study the different types of ISR modes in terms of 8051 and 68HC11. It's one of the famous microcontroller on those days. So basically, interrupt is play a main role, right? Because based on the interrupt, you can set the priority, and based on the priority, you can execute your task. So whenever you want to communicate in terms of a microcontroller, or whenever you communicate with the multiple peripherals at a time, we have to make sure that we have to communicate each and every data or each and every sensors with the peripherals at a time. So I hope that you are getting the idea of what exactly I am trying to convey. Still, if you have any doubt which is related to the DMA, related to the ISR in terms of 8051 and 68HC11, then you can feel free to contact me. So thank you for watching.